Okay, it's 9:40, so let us begin the lab session. Let me go ahead and share my screen. Okay. The first thing that you want to do is that you want to go to your Blackboard folder in Lesson 8 in Lab 8. And similar to what we did before, open the link that you will find in there that will take you to this directory, and you can go ahead and download all these. But as Dr. Cleveland has already said in the chat box, the Lab 8 full narrative and the 01 table data frame.png are optional. I would still recommend that you download all of them because that will kind of reduce the possibilities of getting an error when you're exporting your documents. So download all of them and upload them to your CoCalc directory. And then, similar to what I have here, you will have a list of files, and we are going to start with the Lab 8 reduced size notebook. So I have some bad news and some good news. The bad news is that we are under a little time pressure for this lab. There are some content that I want to cover all of them, and it might be a little too much for this time. But the good news is that Dr. Cleveland has already went over several examples, and at least you are visually familiar with what is happening and you know the content. So for the lab, please try to follow me, and at every step when I ask if you have a question or if there's an issue, just let me know. If you want to run ahead and work on the exercises, I'm just going to let you know that I will not have time to stop the lab and answer questions about the exercises. Although I will be available after the lab if you want to ask a question about this session or previous notebooks and lab sessions, you can just email me right away and I will give you a link. You can join that and we will go over the problems. So, do you have any issues with downloading the files, or shall we begin?
Continue.
Okay. There is nothing in the chat box, so I assume that's good news. Okay. Similar to the previous labs, the first cell box, we want your full name, your R number, your hex code, the title of the notebook, and the date to go on top. Then we will be talking about some examples and some functionalities of the Pandas library or module. As you have probably noticed already, beginning this week, we are talking about some external libraries, and these are kind of creating a smooth shift from the very basic fundamentals and syntax of Python on how to write loops, how to create lists, how to create dictionaries, if statements, while statements, and you're kind of moving from that to more practical tools that you are going to need to deal with different kinds of engineering problems. Pandas is a library that kind of relies on NumPy, which we've already covered in our last week. So it is recommended that you always bring them together. So in the first line, we are importing the NumPy library as NP, and we are importing the Pandas library as PD. When you run that cell on top of your notebook for the rest of this session, for the rest of this notebook, that will be in the memory. Even though, similar to last session, I strongly urge you to keep in mind that you need to import the library in order to be able to use its features and functions. Otherwise, it's going to just put an error and say that function that you're looking for is not defined. So, Panda basically deals with data frames. So similar to the how many things are we downloading? If you look at the comment right above your comment, Dr. Cleveland has given you a list of the things that you're downloading. Download all of them and then upload all of them to your CoCalc notebook. So similar to NumPy, that we use the arrays all the time as the building block. With Panda, that will be data frames. And as already discussed and explained by Dr. Cleveland, data frames have three main components: rows, columns, content. And at every step, you need to be aware of what is happening with that. So, initially, we want to create a data frame using primitive Python. So we are assuming that there is nothing such as Python, such as Panda, and we want to do everything by using the basic Python syntax. Just as a little heads up, if you do not completely understand, or if you have a difficult time following what is happening in the next 2 or 3 cells, that is completely okay. There is a purpose behind that. But if you have a question, go ahead and ask. So let's say that I want to create an object. We are calling that myTabular. And we are using the NumPy package, the function randint. And we want to create a 5x4 array with random numbers from 1 to 100. So that 5 and 4 in the parentheses are basically defining the structure of the n-dimensional array that we want. 5x4, as you know by now, means 5 rows and 4 columns. So if we do that, I'm actually going to add another line. And print myTabular at the end of this. If you run it, you will see that it will give you a 5x4 array right over there. Keep in mind that because we are asking a random number generator, your 5x4 array will not have the same content as mine. So as long as it's a 5x4, you're good. It should not have the exact same numbers. If it gives you the exact same numbers, that is a little creepy. But that is also one possibility. You're getting an error?
Yeah.
What error is that?
NP is not defined, so that's
because my friend, you have not run that first cell we talked about. So make sure that you include that.
Sure.
Then I'm creating another object. I'm calling that my row name. It's going to be a list of 5 strings, A, B, C, D, E. Another object, my call name, W, X, Y, Z, another list of strings. And then I'm saying that I want my table to be formatted as this. So the above builds a placeholder named myTable for the pseudo data frame. Next, we populate the table using a for loop to write the column names in the first row names in the first column, and the table fill. So actually right now, if you go ahead and print myTable, what you will see is just this. It's like an empty shell, an empty skeleton. And in the next cell, we are going to use a couple of for loops to fill that skeleton with the numbers that we have in myTabular object. And we are asking it to go row by row, column by column, and put everything with a similar format that we have. And we are using the length of our row name and calling, which basically means how many rows and how many columns we have, to do the operation. So make sure that you run that cell. And now let's print the table out by row, and we see that we have a data frame like a structure. So if you run the next cell, you will see something like this. If you notice, now you have 6 rows and you have 5 columns. The reason for that is that you have one additional column for your row titles, A, B, C, D, E, and one additional row for your column titles, W, X, Y, Z, but the content of your my tabular object, or the random numbers that you generated, are inside that. So your content is still 5 by 4, but the entire table is 6 by 5. And then we can go ahead and use this data frame-like structure to, let's say, print one entire row or one entire column. But what I want you to notice is how complicated, long, and frustrating this whole thing is for just creating one data frame. And this is something that if you run, it will give you only one element of your data frame. So we're basically going in and saying from the third row, from the third column, go and pick this specific item that I want. And that for my table will be 99. Here is something that you do not have in your notebooks. I've added it myself, actually without asking Dr. Cleveland's permission, so sorry about that. But this is part of a Chinese motto that says, after suffering comes happiness. So now that you have seen how frustrating this entire process is, we are introducing Panda and its features. And you will see how easy it can be. No, you're not here just to suffer. Actually, you're here to enjoy the benefits of using the Panda library. So let us create a similar data frame with 1 to 100 range for our random numbers, a similar structure of 5 by 4, and following that, you can notice that the syntax is pretty organized. We have the strings for our rows and the strings for our columns as lists. PD.dataFrame, and then if you run it, ta-da! Beautiful, clean, easy, efficient, all good. So I think this here simply should tell you why we care about the Panda library. Because it's easy. We always like easy. It's efficient. It's doing whatever we want in a very short and sweet way. Let me have a look at the chat box. Thank you, Brandon. Steban, you can also work on the full narrative, but that is optional, as Dr. Cleveland has mentioned. Roger, for the first example, I only used NumPy to create some random numbers. But the way that I was using the for loops and everything to create a data frame like a structure, that was using primitive Python. But no, generally, NumPy is not primitive Python. NumPy is similar to Panda, and they are external libraries or external modules. So, let us go ahead and see what else we can do with Pandas. We can also turn our table into a data frame. Notice how the constructor adds header, row, and index column. So I can just go ahead and ask the pd.dataframe function to be applied on my table object. And if I run that, you will see that there is a difference between this one and my previous data frame. In this one, I have an additional row, an additional column similar to what you saw in the previous example. And this is basically telling me the index for this data frame. So it starts counting at 0. Python's have it. 0, 1, 2, 3, 4 are the index of my columns. 0, 1, 2, 3, 4, 5 are the index of my rows. It is still the same table, but if you run it like this, it will add the extra column and row. Generally, this is a preferred and recommended format. Much more organized, much more neat. To get proper behavior, we can just reuse our original objects. You can simply create another data frame here. It's called df2. Use the same function, pd.dataframe, and then my tabular, which was my generated 5x4 random numbers, then my row name, and my call name. So instead of like feeding the name of the rows and columns as a list inside the function, you can just, similar to this, you can just define those lists as separate objects, row names and call names, and then when you are defining your data frame, you can just call those objects. And if you run this, the results will be identical. So that is a matter of choice. Whichever you prefer, you can go with that. For some reason that I really can't justify, I always liked this approach better. But I know some people who think something like this is more organized and more standard. So you can pick your favorite one. So now that we have defined our data frame, we can get some information from it. And let's say we want to see how it looks. We can use the shape function, and if you run it, it will tell you that it's a 5x4 data frame. The second data frame that we defined will be a 6x5 because of the reason that I explained, the extra row and the extra column with the indexes. And then our df2 should again be 5x4 because it's quite identical to our df for the first one. So let's say that we have a defined data frame, and for some reason it could be something that we need in our algorithm or some new data that we find and we want to attach. We want to add a new column to our data frame. We can simply go and use this syntax. So what does it mean? It means that I want my notebook, I want Python, to go and find my data frame by the name df and add a column to it by the name new. And in that column, I want it to print NA for all the elements. So if I run this, you will see that this is the new column. And in all the cells, I have NA. That is exactly what I asked for. So in my df data frame, I want a new column. The title of that column or the name of that column is new. And the content of that column is NA. So again, we are playing with the same three fundamental terms: rows, columns, content. Let's say we want to add a new row. That can be even more common. You have already done this, but not with data frames, with tables. In multiple exercises before, you were asked to do computations and then add rows to your table. Here, let's say you want to add a row to your data frame. How does that work? As Dr. Cleveland has mentioned, it is a little trickier, but it's nothing tricky for you. So what do we want to do? We want to create a new object, and we are calling that the new row. Then we want to go to our data frame, df, in location E. Where is location E? Here. And then we want to rename that to be X. So basically the meaning of this line is that we okay, I think the answer to the questions in the chat box are something that Dr. Cleveland can explain. So I'm going to leave that for him. The meaning of that line is that we want to add a new line right after our row E, and we want to name that X. And then my new table, a new object, my new table, is going to be created by using the concat function from the PD or Panda library. And it's gonna take my previous data frame named df and concatenate the new row that I just defined. So if I run this, this will be my new row. And as you see, we are basically making a copy of our E row, putting it next to that and naming that row X. This word, let me just Google it and be done with it.
Looks like you've done that recently.
Yeah, it means that to link things together in a chain or a series. If you have worked with Excel, or if you work with Excel in the future, there is an exact same function in Excel where you have like two words in two different cells and you want to put them together, or you have two numbers in two cells and you want to put them together. So here, what it's doing is that it is putting your new row right in the location that you have defined for in your data frame. What location? E. So all the things that Python needs to know about your new row is defined in the first line. In the second line, you're basically just putting them together. So, do we have any questions about appending new columns and appending new rows?
Just a quick comment. Rows are tricky. It's not designed to deal with row-wise operations easily at all. Column operations are very straightforward. So if you're designing a new data frame from scratch, keep that in mind. If you're going to move stuff between columns, that's easy. That's how you want to structure your frame.
Andrew, you can always Google for something like that. There are people coming up with shortcuts and everything. But generally, as Dr. Cleveland explained again, dealing with columns are way more easier. So I'm going to proceed. We've talked about adding columns and rows. Alejandro, because you're using a random number generator and your numbers are not going to be similar to mine. Max, that is exactly correct. Hunter, yes, you do have a test coming up soon. That was kind of an irrelevant question, though. So, and if you need more information about the exam, Dr. Cleveland is the person who can give you answers. If you need help with the previous documents and everything that you've done in the lab, then I can also answer questions. So keep that in mind. We have talked about adding rows and columns. Let's talk about removing rows and columns. So for some reason, we have a data frame and we decide to to remove a column from it. How does that work? We can go to our new table, a data frame that we have already defined. Use the drop function and then select the column that we want and remove it. So if I run this, you will see that from the previous data frame that we had, the new column is removed. And this way of calling access is very similar to what we did last session in NumPy. So access equal to 1 and access equal to 0. Those are the two accesses that you have within a data frame. So here we just managed to remove one column. And then to remove a row, Dr. Cleveland had this in your notebook, which suggests that you just create a new data frame without that specific row that you want deleted. Something else that you can actually, let me just run that. And here you can just go ahead and define your new table without the row C. And if you do that, the new data frame will have everything you had in the previous data frame without row C. But something else that you can do is you can just use a similar line to what we had with removing columns, like this one. And you can use the drop function, call the row that you want to be deleted, and change access number to 0. And if you do that, you will see that now row A is removed from your table. So this is probably something that you do not have currently in your notebooks. If you want, you can just go ahead and put it there. We are calling what is the access for? We are calling the alignment of the one that we want to remove. So access 0 is going to remove horizontally. Okay. Any questions about removing columns and rows? Okay, good. Let's go to indexing. Tina, that is very, very similar to what you have here, but I'm going to copy that anyway. Here you go. But if you notice, the syntax and the formatting of this command is pretty similar, except for this one, you called your column by title, and then you set access to 1. And for this one, you call your row, and you set your access to 0, and it will go ahead and remove that for you. So for indexing, there are different things that we can do. Let's say that we want to select one single column. We can call our data frame, go with brackets, and then call the column heading or the name of that column. If I do that, you will see that it will go and print the X column for me, 31, 93, 87, 87. I can also call multiple columns. So again, similar to what we had in NumPy. First, you call your data frame. Then, in the brackets that come right after that, you can either go with one string, similar to X, or you can go with a list of strings. And in that list, you will name all the columns that you are interested in. So if I'm interested in column X and column W, I can go ahead and run this, and it will give me all the rows with only column X and column W. That is how to call multiple columns. And now, selecting based on rows, you actually use you can use the LOC or location you have already seen that when we were creating new row here. So in order to call out rows, we use the LOC function. And let's say that I want to call my row E. If I run that, it will print that. Please be mindful of the fact that it is printing it as a column, but it's not a column. Okay? So even though it looks like a column in the output, since you're calling for row E, it is the value of row E. How does it differentiate column X from row X? Well, that's the difference between using this LOC function and not. And then also it is kind of suggested that you do not use the same name, and that is mainly for your own sake, because it keeps your code easier to communicate and easier to follow. But the way to call columns and rows are different, so it's going to be fixed by that. Does it matter the order? What do you mean, Brandon?
So, like, if you look at the code BED XY, does it matter if it's XY BED? Like, look at
no. What happens when you run a line like this is that it goes to your data frame and it will print that column or that row with however order there is. So your data frame could be sorted or not. Python doesn't care. It will print out whatever is there as is.
Okay.
So selecting multiple rows follows a similar logic. So instead of simply calling one string E, you can create and call a list of strings. And let's say we want to call EX and B. It will give us what we want. And if we are interested in a specific elements, so it's not one entire column or one entire row, we want a specific elements, we can go ahead and call them. And with a similar syntax, we have like BED and XY. So it's not the entire row and it's not the entire columns, it's just the specific rows and the specific columns. The logic behind calling them is, again, exactly the same thing. Your list of rows and the list of columns that you're interested in. You put them together, you call the log function to call the location of rows, and you're good to go. So, do we have any questions about indexing the notebooks? The data frame, sorry. All good? Okay. Cool. Let us move on to conditional selection. Here we are defining a data frame, and I want you to pay attention to the different method of defining it. So it is quite different from our previous DF that we defined. We are using a dictionary to create a data frame. This dictionary has, similar to the dictionaries that we have already covered in our first week, it has keys and it has data. So the first key is call1, and then it has some data. 1, 2, 3, 4, 5, 6, 7, 8. Then we have call2, which is our second key, and then it's data. And then we have the third key and the data associated with that, which in this case is a list of strings. And if you look at the outcome, you will see that each key that you have up there is being interpreted as the heading of a specific column. So if you have 3 keys, it will give you 3 columns. And the data associated with each key is going to fill the elements or the cells right below that column. So for call 1, we have 1 until 8. For call 2, we have 4, 4, 4, 5, 5, 5, 6, 6, 6, and so on. And for call 3, we have our strings, which are our fruit names. Orange, apple, grape, mango, jackfruit, watermelon, banana, peach. That's one way of defining a data frame. And now that we've done that, let's say that we are interested in knowing what fruit corresponds to the number 555 in column 2. How do we get that? We first call the data frame that we want to work on. The name is df. Why? Because we said so. So, first we call that. Then we say, I want you to tell me the content of column 3 when the content of column 2 is equal to 555. So let's have a look at the syntax again. I'm asking Python to go and look at my data frame called df and tell me what is the content of column 3 when the content of column 2 is 555. And if I run this, it will tell me apple. Why? Because in column 2, when I'm 555, in column 3, I have apple. Now, if I go in and change this to 222, it will tell me banana and peach. Why? Because in column 2, I have 2 instances that my content is 222. And it will report both of them, banana and peach. Why do we need df the second time? Because we are saying, I want the content of column 3 when the column 2 of df is equal to 222. Without that df, call 2 has no meaning. Call 2 in that brackets is a part of df, and Python needs that in order to run the command for you. Roger, was that a good enough answer? Cool. So you can do a little more with that, and you can say, okay, what fruit corresponds to the minimum number in column? So in this one, you don't really know if you want 555 or you want 222. What you know is that you want to know what fruit corresponds to the number that is the minimum in that column. What you do is very similar. Go to my df data frame. Tell me the content of my call 3 when my column 2 of data frame df is equal to the minimum value of that column. So it is kind of expanding in length, but if you follow the logic behind it, it is pretty communicative. And if you run that, it will tell you watermelon. Why? Because if you look at this list, the minimum is 111, and the fruit associated with 111 in column 2 is watermelon. Okay. Do you have a question about conditional selections? Looking at the chat box. 1. Looking at the chat box. 2. Looking at the chat box. 3. Sold. Okay. The descriptor functions. You may not fully appreciate the benefits and the advantages of these functions yet, but I promise you that you will in the future. I'm not even sure if that will be in this semester or your next semesters to come, but I promise you that this will happen. So, what are descriptor functions? They are a bunch of functions, not just one. that you run on your data frame, and they try to describe different aspects of your data frame for you. Depending on what you're dealing with, you might be interested in different things about your data frame. Now, we are creating our data frame here again in a similar way using a dictionary, call 1, call 2, call 3, and the same content. So we can run that cell. And it will give us the new data frame. Now, we can use the head function from the head function on our data frame df. And what it does is that it gives us a view, a glimpse of the first part of each column. So let's say that I'm working with a data frame of temperatures for Lubbock for the past 10 years. So if that is daily temperatures, and we assume that we only have one measurement in every day, that will have more than 3,650 columns. But if I run this function on it, it will still show me the first 5 entries. But it will be enough for me to see, okay, is this the right data frame that I've called in? Does it have what I was looking for? Looking at the numbers, I can say, oh, is it degrees Celsius? Is it Fahrenheit? So the head function will give you a glimpse of the first rows of your data frame. If you have 10 columns, when you run this, it will show you all the 10 columns, but only the first rows. So keep that in mind. The head function shows you all the columns, but only the first 5 entries, similar to what you're seeing here. So instead of head, if you run info, so df.info, it will give you some overall information about your data frame. In many cases, many of them may not be useful for you. So, for example, when I run it on my df data frame, it is telling me that it is a Panda data frame object. The range of index goes from 0 to 7 for rows. It has 3 columns. The type of each column, the first 2 are integers, and the third one is an object. And then how much memory usage it has. So depending on what you want to do, you may find pieces of this information more useful than the others. But that is what the info function tells you about your data frame. We can use the describe function. And if you run it on our data frame, it will give you a few numeric information about your data frame. So, what is the count? How many numbers, how many rows you have under your columns? What is the mean value? What is the standard deviation? And then it gives you something that in the world of statistics is called the 5-number summary. The 5-number summary can tell you a lot about a range of numbers that you have, or a sequence of numbers that you have. It tells you what is the minimum value. It tells you what is the maximum value. It tells you where the median falls. It tells you where the 25%, the 75% falls. So you may not have been engaged with the statistics that much yet, but the more you grow as engineers, you will realize that nowadays it is almost impossible to do any engineering project without having a statistics involved to some level. And that is a very basic level of a statistic that you will play with. This 5-number summary actually has a more visual representation that is called the box plot. If you're interested, you can Google that and have a look at that. But knowing these 5 numbers, minimum, maximum, median, 25% and 75%, or the first quantile and the third quantile, can tell you a lot about the data that you're dealing with. I want you to pay attention to the fact that even though your data frame DF has 3 columns, you are only looking at 2 of them here. The reason for that is that the contents of your third column were not numbers. And you simply cannot calculate the mean, the standard deviation, the maximum for a non-numeric object. So that is the reason that you have only 2 columns here. Do you have any questions about these 3 interesting and beautiful functions? Head, info, and describe. Questions 1, questions 2, questions 3. Okay. So let us have a look at some other things that we can do with our data frame. We can select a column or a row if you want and do some operations on it. For example, we can go ahead and say from my data frame DF, choose the contents of column 2 and apply the operation sum on it. So the output of this will be one number, and that number is the summation of all and everything that you have in call 2. You can multiply them, you can subtract them, you can divide them, and all these little operations. So that is something that you can do with a data frame. That will be very useful, and that will be very similar to what you can do in Excel. So let's say that I have an Excel file. I can go right to the bottom of the cell and create equal SUM, open parentheses, equal, select everything that is in that column, close parentheses, hit enter, and that will give me that. You can do that with one line of code in Python. I'm not sure how much you've used Excel, but I assume you've used it more than Python. That's why I used that example. So another thing that we can use, Dr. Cleveland has already been over it, is the use of unique and unique functions. So the unique function will tell you how many unique elements or unique numbers you have in a column. And the way that unique is defined, it means that you have that element and nothing similar to it. So if I have a list that has 1, 2, 3, 3, 3, 4, how many unique values do I have? I have 4 unique values, 1, 2, 3, 4. And the fact that 3 has been repeated 3 times doesn't mean that we have to count it 3 times as a unique number. So, okay, Dr. Cleveland has been helping with the chat box. Thank you very much. So if I run this on my call 2, you will see that it will tell me I have 5 unique values in my call 2. 444, 555, 666, 111, and 222. However, if I go up there and look at my data frame, you will see that I have 2 rows with the value 222. But in my unique values, I only see that once. And I know that I also have 2 444s, so similar with that. Unique numbers tell you how many numbers you have repeated at least once. Or existing at least once, that's not repeated. So unique will tell you the number of that. So if you compare this number 5 with what we have here, this is simply telling me the count of this list or of this array. When I run the unique function, it will tell me the unique values. When I run the unique function, it will tell me how many unique values do I have. Combining those two, we have the value underline counts function that will actually show me something like this. and it has all the information from the two of them. So first, it is giving me a list of all my unique values: 222, 444, 666, 111, 555. And then it is telling me how many times each of them exist in my column. So I have two 222s, two 444, and two 666. I have one 111 and one 555. So personally, I like this one better because for one line of code, it is giving you more information in a very descriptive and compact manner. But it's always beneficial to know the application of each one of them. So unique, and value underline counts are the three functions that can give you some information about the content of your data frame and columns. Do we have any questions about this?
See what happens if you put a sort at the end of that command? Value counts dot sort as a function. I'm curious if it'll reorganize them from 111.
You mean after the parentheses we go
Correct.
with sort like this?
Yeah, it might fail. So I may have the syntax wrong. Yeah.
Yeah, series object has no attribute sort.
Yeah, so it needs to be assigned to a new data frame before you could sort it. That would be cool though if it could all be done in one deal.
Yeah, it still doesn't like that.
We'll say that for a future exercise for a future class.
Yeah.
So y'all lucked out today.
So, if we have no questions on this, we can go ahead and talk about something useful, another useful thing as well, which is applying functions on data frames. Or the symbolic apply. So this is one of the features that make Pandas extremely popular among data scientists and people who use it, is that it gives you the opportunity of applying a function on all of the elements of your data frame. You are kind of familiar with this concept because we talked about it in NumPy. So NumPy can do the same thing with arrays, and Panda will give you the power of doing that with data frames. So let's see what we have here. We have a function here called times2. This is a prototype function to scalar multiply an object x by 2. What it does is that it asks for a value x, and then it returns that value multiplied by 2. What we want to do is that we want to define this function in these two lines. Then we want to print our original data frame df. Then we want to print this string, apply the time2 function to call to. And then we want to go to our data frame df, the second column of that data frame, the call to column of that data frame, and then use this dot apply function to apply the times2 function on that column. So this is the symbolic apply function or method. So if I run that, what will I see? Initially, this is my original data frame df. This is the string that I asked for, and this is the output of my last line. What is happening? It is going and looking at my call to from data frame df, and it is applying the times2 function on them, which means that it will take each one of them and multiply them by 2. So instead of 444, I have 888, and so on. So the syntax is quite simple. The name of your data frame, the column that you are interested in, dot apply, and in parentheses, the name of the function that you want to apply. In our case, in our example, that was the times2 function that we defined right on top of this cell. Do you have a question? 1, 2, 3. Okay. Now, something else that we have here is about sorting. And similar to what we saw with NumPy, we can sort data frames defined in Panda. So we can go and say, I want my df data frame, and I want the sort underline values functions to be applied on call to and in an ascending manner. So if I run this, it will give me a sorted version of my data frame. If you look at the first column, the column of index, you will see that these numbers are all messed up because initially they were named and indexed with the initial order, but now the order is ascending with respect to the content of call to. And if you look at that, you see that it starts at the minimum and it ends up at the maximum and it moves in an ascending order. So if I change this to false and run it, you will see that it will be the other way around. So it starts with the maximum number on top and then it goes down to 111. That is how sorting works in Panda data frames. Yours says key error call to. Are you sure that you have ran the data frame correctly before? Because that probably means that it can't find the call to name for your column. I hope that has resolved the issue. If not, we can work on it after the lab next. Yeah. So, for your exercise 1, you're asked to create a prototype function to compute the cube root of a numeric object, literally 2 lines to define the function. Recall explanation is available in primitive Python. That should be nothing for you. And then apply your function to column X of data frame new table created above. So if you go up in the same notebook, you will find somewhere that we have defined a data frame called new table, and that had a column named X. We want you to create a function for computing the cube root of a numeric object, and then apply that on the X column of the new table data frame. Pretty much identical to what happened here. So if you look at this, you should be able to do it in less than 3 minutes, I would say. So, aggregating or grouping values in data frame context. Another extremely vital thing that you will need to do with data frames is that to group columns or rows together by how you need. Okay, actually, I was asked to check something. Let me go.
That looks good.
We define the new table. Where do we define it? Here. This is initially where you define the new table function. And if you notice, you will have an X column in this. So If you want, you can actually define the function again in that cell code to be sure that you have everything, and then apply your function on column X.
Yeah, it's that new table that you want to use.
Pardon?
That was the version of new table that's intended for that exercise.
Yes. So, yeah, let's say that we want to create an object, a dictionary, and we are naming that data. It has 4 keys and, of course, 4 sets of data associated with the keys. And then we are creating a data frame. We are calling that df1 based on data. If I run this, as you expected, we have 4 columns. The first one is key, the second one is data 1, data 2, data 3, and then all the contents. Then let's say that I want to group and sum all the values in all the columns based on the column key. So let's run this and let's look at what is happening. We want Python to go and look at our data frame called df1. And then we want to group it by key. And then we want the values that are grouped to be summed. What does that mean? I have key, in my column key, I have A, B, C, A, B, C. So when I ask Python to group my elements based on key, I'm basically saying that go in and see how many elements I have with the key A and group them together. So I have 2 elements with key A, and 1 and 4 are going to be in one group. And then I'm using the operation sum, so I will get the value of 1 and 4 added and printed here as 5. I will have the number 10 plus 13 added together to be 23 and printed here. Then number 20 and number 13 to be 33 and put there. How many objects do I have with class B? Again, 2. Those will be grouped, summed up. How many values do I have with key 3? Again, 2. Grouped together, summed up. And that is what we wanted to do. So let's say in my temperature data example, I want to group all the Saturdays in the 10-year history of Lubbock. So I will have one column with the days that goes from like Sunday, Monday, Tuesday, blah, blah, blah. I can go ahead and ask Python to group all the temperatures that have been recorded on a Saturday. And then I can get a mean and say, okay, on average, the temperature of Saturdays over the past 10 years has been this number. That's not going to be a meaningful output, but the idea behind it is similar. So we are grouping by a key or an attribute that can be similar between multiple entries. So let's see what is happening here. We're grouping and summing values into selected columns based on the column key. So let's say I don't want that operation to be done on all my columns. I just want that to be done on my column data 1 and data 2. So I will say, okay, pick my df1 data frame, group by key, but rather than just summing everything, only sum the values that are located in column data 1 and data 2. And the output will be only these 2 columns. Okay. Dooley, thank you very much for bringing that up. I think I have said that many times by this point. So for those who have already heard me, I apologize. But ladies and gentlemen, please stop trying to export the full narrative or the version of the notebook that we work on during the lab. You are given you're given a worksheet only, and if you do not have that, if you haven't downloaded that, if that is not provided to you, you can simply cut all the examples and exercises that you have worked on and put that in a separate notebook and try to export that as a PDF, because experience has proven that sometimes Dr. Cleveland and I have image files in our notebooks, have raw cells, and when you try to export that, your notebook will not be able to run those cells, and it will give you an error and it will make you frustrated. So in order to avoid that, simply give us a notebook of the examples and the exercises with your work, because we need that to grade your assignment. Is this not the worksheet for this one? No, this is not the worksheet. Wherever you see markdown cells with explanations, that means that is a class notebook. So even if you do not have the worksheet only, you can just simply go in and remove all those explanation cells up until a point that you only have the examples and the exercises. So if you have any more questions about that, let me know after the lab. We are dangerously running out of time, so I have to probably run through the next parts.
Take the time you need, because I'm just going to delay my next class until you're done.
Okay, thank you. I really appreciate it. So about filtering out missing values. Again, to go back to my temperature example, let's say that I was measuring temperatures for every day for the past 10 years. For some reasons, let's say technical issues, there has been a few days in the past 3,600 days that my thermometer didn't work. And for those days, I do not have a temperature measurement. That is called a missing value. So in a series, in a time series, or in a series of number that has been recorded since the past 10 years, there are a few entries with no values or with missing values. And Panda and its functions allows us to kind of deal with that in an appropriate manner. So let's say that I have a data frame like this. It has 3 columns, col 1, col 2, col 3. And it has some missing values. In those missing values, when we were defining it, we said none because we had no values. And then when you look at it, it is being shown as NAM. So when there is no number, it will just show you N again. Why do we care about that? Because if you want to start doing numeric operations on these columns, those nasty little NANs are going to become a huge headache, and you want to handle them right before you start doing all your serious stuff on your data. So what are the ways that we have? We can simply go in and use the drop NA function, apply that on our data frame, and the output will be this. So it simply goes into my original data frame, looks at every row, and as soon as it hits an NAN, it removes that entire row. That might be an option to go with when you have a huge data set and very, very limited missing values. So you have like 2 missing values in 100,000 records. That might be something that you want to go with. But usually that is not what we want to do, because we don't want to lose data. Data is a rare and expensive item to have, and when we have it, we don't want to lose it. So what else we can do? You can ask Python to go and replace those missing values or those NaNs with something else that works better for you. So for example, you can ask Python by using the fillNA function to go in, and wherever there is an NaN, it will put a 0 for you. If I run it, you will see that I'm not missing my entire rows because of one NaN, but instead I'm getting a 0 value wherever that is a missing value. That is one way of dealing with things, but let's say that I want to calculate the average value of my call2 in this example. I have values in the range of 444, 666, 222, so all these big numbers. And then all of a sudden, because I have two missing values, I have 2 zeros in there. If I calculate the mean value right now, that number will be incorrect and biased, because actually I didn't have zeros there. Actually, I missed an opportunity to record the data in that day or in that entry. So I don't want a 0 in there to mess up my calculations. So what I can do is I can go ahead and ask Python to replace my missing values with the average of the rest of that column. In that way, I'm not messing with my average value in the same scale. I want you to realize that when we have missing value, there is no ideal way that will give us the exact accurate measurements of that value. If we had that, we had no issues. So we have a problem. We have an engineering problem, and it's that we have missed our chance to do some recordings. And now we are coming up with different solutions to make up for that by reducing how hard it can hurt our analysis, our project, our research. So I can go and ask the same syntax, fillNA.df, and replace the values with the average or mean of the values that I already have. So if I run this, I do not get zeros anymore. I get like 407. And that 407 is still an artificially created number, but because of the way I defined it, it is messing with my average value to a lesser degree. I'm not sure if I could communicate with you the importance of filtering and filling data, but that is something very, very important, whatever field of engineering you want to deal with. So, do you have a question about this part? About missing values and how to fill them? Cool. For exercise 2, you are asked to replace the NaNs with the string missing in the data frame df. So in the same data frame that we already worked on, we want you to go in and replace all the NaNs with a string that says missing. Again, I think this should be very, very easy for you because you have already seen 3 examples with the same content. So I'm not going to give you a hint because
you don't need one.
Knows the problem. So here is something Dr. Cleveland has left for you. That should be more than enough. Just go with a string. The last thing that we want to work on for this lab is how to read a file into a data frame and how to write it. In many cases, when you want to access data, you will go to different websites, different online resources, and you download data files, usually as a CSV file or sometimes an Excel file. and you need to bring them into your notebook and Python environment to be able to play around with them, do your calculations, run your codes and everything, all the fancy things that you want to do. So when you're using CoCalc, because of this beautifully colored ribbon that you constantly see on top of your screen, and because of the fact that we are not paying for the license, it does not allow us to download data sets directly. So if you are working on your own machine, you can do that. But if you're using CoCalc, you actually need to go and download data sets and then upload them to your working directory and then call them in, similar to what we are doing in every lab. Download your data frame, upload it to your working directory, which is basically this list, and then call that in. Here, we are going to tell you how to call in a data file. In the files that you've downloaded from this list, there is a file that is called csv_reading_file.csv. With this line of code, I can go in and read a CSV file. And CSV stands for comma separated. I'm not sure what V stands for.
Values.
Values, okay, thank you. And you can open CSV files in Excel as well. You just need to go and do one tiny thing to make them look more of a familiar Excel file. But generally, you can also open them in a notepad as a text file. They're just a bunch of values in a kind of an unorganized manner. But they are kind of the best way of working with codes, both in Python and in other languages like R. So, what are we doing? We are creating an object. We are calling that read file CSV equal. From the Panda library, we are calling the read_CSV function, and we are giving the name of the file that we have in our working directory. So if you have a file that is named data temperature Lubbock, here you will put in data temperature Lubbock. The rest of this, the pd.read_CSV is the syntax of calling that function. So when I run this, it will show me this. That is the content of that CSV_reading file that we just brought in. And if you want to read an Excel file, you follow a very similar approach. So look at the next cell. We have an object that is called read file Excel. And then again, pd dot, instead of read_CSV, we are using read_Excel. And then we call the Excel file that we want to read in, and then we call the sheet name that we want to read. So let's say that we have an Excel file with multiple sheets in it, but we are only interested in sheet 2. Here we just call that sheet by name. And if I run this, it will show me the content of that Excel file. That's it. So the pd.read_CSV for reading CSV files, pd.read_Excel for reading Excel files. And that's how we bring in a file, a data file that already exists. Now let's say that we want to write a data frame. I believe at this point you are kind of seeing the similarities between what we are talking about right now and the file manipulation lab that we did last week. So in this one, we first read a CSV file that we have. We are creating an object. We are using the read_CSV function from the Panda library, and we are reading this specific file. Then we are using this to_CSV function to create another file in our working directory. So what you need to keep in mind is that whatever you read should be in your working directory, and whatever you write will be in your working directory. And then after writing that, we kind of go in and read that again. So this will be the outcome. But what has happened here is that you have read a file, you have wrote that on another file, and then you are reading your new file. That is the steps that are happening here. Then in the next cell, we are creating and writing to a CSV file by excluding row labels. So a similar approach as the upper cell. Instead, if you look at this part, that is the difference of what's happening. So in this one, when you are writing your CSV file, you are saying that I don't want my index to be included. Index was the same thing that I showed you in the beginning of this lab, where you have an extra row or extra column with the number of your index. So here you can see that index was printed for the upper cell. But if I run this, you will see that we don't have this extra row index right up there. So if you want that to be included, just let it be. If you want that to be removed or not included, go with index equal to false. And in the next cell, I believe if you run this, it will give you an error. Yes. And the reason for that error is that we have this index equal false in our read function. So I want you to go ahead and remove that from the first and the third line. This is very similar to what we did before, but for an Excel file, not a CSV. And if you run it, this time, it will show you this. The difference between these two is that in the second version, this is an Excel file, and you can easily open that in Excel and see that in organized rows and columns. In the first one, it was a CSV file. And you can actually go ahead and download them and open them in Excel and see the difference. If you open a CSV file in Excel, initially, all the numbers will be in one cell. There is a way, there is an actually easy way to communicate with Excel and ask it to show that in the right way. But initially, Excel will open a CSV file in a little weird way. So, for exercise 3, you are asked to download the file named concretedata.xls if you have not done so yet. So, in the same list of files, this is the file that you are asked to download. I believe you have already downloaded and you have already uploaded into your CoCalc. If you have not done so, you can go into that link and do that. Then, you are asked to read the file into a data frame named concrete data. Then you are asked to perform the following activities. 1. Examine the first few rows of the data frame and describe the structure using words in a markdown cell just after you run the descriptor method. This should not be a code cell. This should be a markdown cell because you're basically explaining something like a paragraph or a few sentences. Number 2, simplify the column names to cement, blast furnace slag, and so on. So we want you to go in and put these strings as the column headings for the data frame. Then number 3, we want you to determine and report summary statistics for each of the columns. Summary statistics, 5-member summaries. We have already been over this. It's one of the descriptor functions, the one that I liked in particular. So then in number 4, you're asked to insert and run the script below into your notebook after the summary statistics. Describe the output using words in a markdown cell. And I promise you, this is going to give you something extremely cool and very, very useful. So this should be copied and pasted into a code cell right after you've done everything. Then it will give you something very interesting. You will look at that and write a little markdown cell about it.
I have can you go up the cells above exercise 3? Yeah, that cell right there, creating and writing the XLSX. I got an error. What do you do to fix it?
I removed something like this that was included in this line and in this line.
Oh, you removed the index.
Index equal to false from the first line and the third line.
I'm getting a name PD is not defined error.
Come again?
I'm getting an error that says name PD is not defined.
That is because you have not imported your Panda library. Go ahead and do that again.
Sure.
And make sure you run it.
Does it work?
I'm looking for the Panda library.
Okay.
Or like where it should be running.
Should be at the top. It's the first cell.
Since we are running out of time, I'm just going to tell you something about this lab that is quite different from the previous lab. We have 3 exercises here. Honestly, exercise 1 and exercise 2 are extremely easy. They can be done in 5 minutes. But something important that you need to do, and I strongly recommend it to do, I have heard Dr. Cleveland also told you to do that. Go ahead, use Google and do some reading on Panda and its different functionalities. That's going to be really, really useful. This is another thing that you do not have in your notebooks. I put it there for you to give you a little bit of a positive vibe at the end of this. So with a little bit of practice, you will be cool as a Panda. Panda library is extremely useful. I promise you that once you know your way around it, it will be helpful to you in countless occasions. So I am done with the lab, and I'm going to pass it back to Dr. Cleveland so that he can close the session. If you have any questions or if you need assistance with something, something about your notebooks or anything, just email me right now and I will send you another Zoom link so that you can come and discuss your work. Thank you very much. Be safe, Dr. Cleveland. I am passing you.
Before you unshare, I wanted you to just scroll up. Go ahead and reshare your screen.
My screen?
Yeah.
Okay. You need to make me host again.
Only because it's fast. Oh, you de-hosted.
Yes.
Let me see if I have mine up and running and I can... I'll do it from here if it will let me. Oh, I hate it when that happens. I just want to spend a couple seconds and then Tina, yeah, I don't know what it is with the animals. It's just how computer people are. They're weird. And it's not going to work, is it? Do I have it back yet?
Your screen is not shared yet.
I know that. I will get that going. There we go.
Okay.
All right. I have a stalled version. Come on. Oh. Well, oh, Greg, that actually worked. Oh, I hope I don't regret that. Excellent. Okay, so in this last exercise, this step, which is renaming the columns, is not the easiest thing in the world to do. Reading the file, you have plenty of guidance up above on how to do that. Describing the data model, it actually tells you the method to use, and then you would insert a cell between these two and write in words what the data model is. Then renaming the columns. There is an example way up above where we rename a column. And you just need to attempt to extend that to multiple columns. And there's also a hint. There's a text file that has a hint on how to do that if you want to try to automate it. But what I'm hoping you'll do is go to pandas.org and search for how do I rename a column and read the guidance there. The entire exercise can be done without renaming columns, but it's really hard to interpret the output because they have really long names. Then use a method to get summary statistics. It actually even kind of tells you the method in the directive. And then the last part is kind of supposed to be a gift. It should make a fairly cool plot for you. The key thing on the last part is to be sure that your data frame has that name, or if you want to use a different name, that's fine. You'll need to change it in this directive right here. And that's all I have for Lab 8. You probably want to start on it while this is fresh in memory. I will get the videos posted as soon as they can be rendered. And with that, I am now going to shut everything down. And
Dr. Cleveland, there is a question. Some students want to know if this lab will be included in the midterm exam.
Actually, I think in that last group team meeting, yes, Pandas is part of the midterm exam. And I don't think you should worry about it. If you can get this third exercise done, you should be very well prepared for anything that's likely to come up from the instructor team. I'm positive. I'm positive of that, and I think Farang can back me up on that.
Yeah. Honestly, I would say that you students of our group have nothing to worry about because of the material that I know we've covered in the labs, and I will talk with Dr. Cleveland later this week, and we will probably make an announcement because I'm thinking of holding a special office hour during the weekend in case some of the students may want to go over their previous lab notes.
And then
is our midterm going to be administered like the quizzes have been?
It's going to be it's going to be a combination of both. There's an in-class portion which will be handled during a laboratory period, and a quiz will come to life. You'll have however long that lab is, an hour and 20 minutes to complete that quiz, and then it disappears. It turns into a pumpkin. But there's a take-home portion that will be a lot like an exercise. You have 24 hours to do that, and that's to remove any time pressure. Obviously, the 24-hour one will have probably actual programming activities on it, whereas a hour and 20-minute quiz is going to mostly be multiple guess or really short questions, or this is an error, fix it kind of stuff. That's the format I intend to use unless I'm instructed otherwise by the other instructors on the team.
Okay, and we're still scheduled for next Monday for that, or Tuesday?
Tuesday, yes.
Okay, perfect.
Well, actually, that's a good question. Let me check the syllabus on that.
Because I saw we haven't done Lesson 9, and Lesson 9 was supposed to be done today, so I wasn't sure if we were rescheduling it or keeping it for the same time.
The issue with the numbering could be the fact that initially we were counting from 0, like Python, but now we're counting from 1. So I think we have covered everything that we wanted.
I'll check our syllabus. The exam for this is scheduled, oh no, not that exam, that would be 22nd of September, which is next Thursday.
Tuesday. 22nd of September will be Tuesday.
I got 2/15. So today's the 17th?
Yes.
So that would be 22nd. It's going to be 24th. I have a screw up in the syllabus.
Okay, then it's going to be on Thursday.
It's going to be
Thursday.
Next Thursday. The the lesson for that next Thursday I have listed as review of NumPy, Pandas, and Matplotlib. And then midterm 1 starts in the lab, and you'll have an in-class portion as well as a take-home portion.
Okay, perfect.
And that's the plan for that. Man, I got to remake this whole table. Damn it! The one problem with the Markdown structure is a single mistake in a table. You have to manually rebuild the whole thing.
Yeah.
So other than me just complaining about it, that's not a big deal. And that's all I have for today. I actually have to terminate the call because I have another class that started 15 minutes ago, and if I wait too long, no one will show up. So
Okay.
have
Thank you.
a great
Take care. Be
afternoon,
safe.
and have a good weekend, everybody. Be safe.
You too.
And Farang, thank you. That was an excellent lab.
Thank you.
Goodbye.
Bye.
Drops on me. Well,